right, fluid applied membranes. The cold fluid applied membrane, this is the NRCA waterproofing manual that I had put on SharePoint for you guys. So if you get a chance to access that, I'd like you to read that. And, you know, primarily the roofing section, which would be the horizontal, it does cover subgrade and a lot of different applications. And that was one of the challenges when I put this program together, was kind of defining exactly what cold liquid applied membranes were for roofing, because there's so much of a crossover, not only with the coatings that we talked about last week, but with waterproofing in general. Where does waterproofing start? Liquid applied. What constitutes a liquid applied membrane? And I kind of looked at that, and we'll define it here in the next couple slides. So vertical wall and subgrade roofing applications are not included in this module. We have another module on waterproofing and damp proofing, nor are SPF applications included here. Cold fluid applied membrane module reviews common cold applied systems which are constructed in situ. When somebody says in situ, they mean in the field. So if something's made in the field. And that's one of the benefits and one of the selling points of these systems, is that they're quote unquote monolithic. So there are no seams. So with the absence of seams, we know when we're fixing. 90% of the time, my repair guys out there know when you're fixing something, you're probably fixing something either at a flashing condition or a seam. So if you have a monolithic product, you have no seams. So the fact that they're eliminating the seams tends to make them good candidates. And what we'll talk about here, use these products a lot of times as with overburden on them. So you'll put one of these systems down, and then you'll put dirt on top of it in a planter situation. You may put pavers on top of it. You may use it as a wearing surface for driving. You may pour concrete on top of it. That's a common practice in high-rise construction. So you've got to make sure that these systems don't leak, that they last a long time. Okay, so they are and they're unique in that you build them in the field. So when we build sheet product in the factory, it's a very controlled environment. So really the seams are the only main places that we have a problem at the end of the day. So when you build these systems in the field, you're subject to environmental conditions. So one of the key applications and installation considerations with these systems are the environmental conditions that you're putting them down with on a daily basis. And if you're going to have a product failure, we're going to find out that's probably one of the main places that you're going to have it. So the objectives for today, we want to understand the difference between a coating, which we talked about last week, again, which is mainly to extend the life of a roof system, a fluid applied membrane roof system, and waterproof. Understand the two major classifications of fluid applied roof systems, determine suitable substrates for fluid applied membrane and roofing deck preparation required, understand the application processes for various cold fluid applied roofing membrane systems. We're going to review the common flashing details associated with them and reinforce cold fluid membrane system in the lab. The lab is something that we're going to follow up on. Fort Lauderdale, we're going to do that the weekend, I believe, of the 20th. And I'm working on a trip to Orlando the week of the 18th. So more information coming on that. One of the things I do want to do is get through this program a little bit early today. We stayed a little bit late. Thank you. I thought it was a great back and forth with Daniel last week from GAF, and we talked about acrylic systems. We're going to talk about acrylic systems today. We talked about urethane systems. We're going to talk about more about urethane systems today, both single component and dual component. Those are key terms that I want you to take away. And then we're going to talk about two other systems, PMMA and PUMA, a little more detailed systems that have some unique characteristics to them. So what's the difference between a cold liquid membrane system, a roof coating, and waterproofing? Because they all come out of a bucket, and a lot of times they have the same base materials in them, acrylics, urethanes. Well, what we're talking about today is a fluid applied membrane system is defined as a fluid applied, and it may have reinforcement, it may not have reinforcement. Depends on what kind of substrate you're going over. And many times your critical areas are reinforced. It may depend on what length warranty that you have on that system as to whether or not it has reinforcement in it. We're also looking at systems that can be permitted as a roof system under the Florida Building Code. Now, what I found out in the past, because I work in a lot of places, and Mike, I'd like you to comment on this as we go forward, is that different areas of the state have different requirements. In South Florida, doing a coating system, need to make sure that to the building department, I hand in moisture surveys done by a third party, a lab, for instance. When I went to do a coating job in the market in Tampa, and I went to get a permit, I brought them my moisture survey. They asked me, what's that for? And they gave it back to me. And after spending $2,500 on a moisture survey, I was not only a little embarrassed, but I learned a good lesson. But at the end of the day, for me as a contractor, I wanted to do my due diligence regardless, because I don't want to apply any type of a coating over a wet substrate. And we'll talk about that, and we'll talk about it a little deeper, because it's not just surface moisture, Frank, right?
Yeah, yes, correct.
We can have moisture in the concrete. So, and again, that's why I asked Frank to be here, so he could shed light on some of the issues and the importance of quality control in the field when you're putting down a liquid applied membrane, and what you need to do to make sure you have a successful project. Sorry. Waterproofing employs the same basic definition as cold fluid membrane, but applies to all aspects of the structure other than the roof. They waterproof the walls, and they use a lot of waterproofing below grade also to prevent moisture, especially where you have subgrade structures. We talked about coatings last week as being a fluid system applied to increase the lifespan of an existing roof by reducing the UV and weathering impacts to the system. Also, we talked about increasing the SRI for a roof system, the SRI being a component of the reflectance of the roof system to reduce heating and cooling costs in the building also. So as a byproduct of having a white roof in Florida is reducing your cooling costs due to the reduction in the heat load. Cold applied membrane systems have been in the market for over 50 years, some with a lot more success than the others. I have gray hair. Some of us on the panel have gray hair, probably because we got into these systems a long time ago. If we have hair, I guess that's a good point. Because we got into these systems a long time ago, and some of the early ones did not perform well. So if you were an early adapter to some of these and you bought into them a little bit early, you sometimes got left holding the bag, along with, for instance, some early other systems. Research and development is like that. There were some failures in early TPOs along the way. These systems were traditionally designed primarily to eliminate the impact of hot. So they used cold fluid applied systems and started with asphalt-based products a lot, and cutbacks to get away from hot bitumen in places where you couldn't use hot bitumen, or the smell of the hot bitumen was an issue also. The use of cold applied systems was traditionally restricted to repair and maintenance of larger systems. And as a repairman, that's what I've used. I love Apox thermoplastic for re-graveling and for repair and built-up roofs when I'm doing repairs, when I only need to put down less than a square. So a little bit about the history. Cold fluid applied polyester products were developed in Europe approximately 50 years ago. A lot of this chemistry and a lot of the stuff we use in roofing does seem to come out of Europe. And if you could address that maybe on an R&D side, Glenn, when you get a chance, coming from the manufacturing industry a little bit, why is that? Are they ahead of us on the technology side?
I don't know exactly the push or the thrust of it, but it does show, and when you look at history and look at research, they've embraced the liquid applieds a lot more readily than we have. A lot of it, I believe, is some of the environmental concerns they had with the asphaltic systems and whatnot. They were always pushing for something a little bit more on the what I would consider a green roof, if you will. And even with these products, there still is a lot of R&D and a lot of push to try to make these things even more environmentally friendly. Just to give you an idea, you're going to be talking about a product, AlphaGuard or Bio. You know, you're going to hear the term bio and alpha, and you're going to hear the term renewable and those type terms. A lot of that came from a thrust that came out of Europe. They're just constantly pushing the envelope in regards to renewable, eco-friendly, but by and large, they were looking because the type of construction and so forth, it just lent itself as a little bit more conducive on the safety side of things, space, you name it. But I don't know exactly all of the thrust or the specific thrust, if you will, but there's quite a few factors that did push them that way. But you know, that aside, it's evident that they've embraced that technology and have really really embraced it, really pushed it, and that's where it originates from. To this day, I mean, like the PMMAs and so forth that we've started really embracing and really looking into and using. They've been using for the last 20 years as a staple. So, I mean, they just seem to be ahead of the curve for whatever reason.
And guys, where you're going to find a lot of these projects are a lot of times in products, and we talk about things like PMMAs, which is actually a kind of hard acrylic resin at the end of the day. It almost makes like a plastic. And if you'll notice, we're talking about polymers and we're talking about APP. They're plastics. Those are some of the modifiers that are in the roofing products that we use on a daily basis. So Kemper, you see Kemper, that's a roofing or a waterproofing system manufacturer. So, you know, it goes back to them many years ago in Germany. And I do know that a lot of them, the products come out of Europe, it seems like, as far as, you know, the chemical, you know, the innovations and before they come here. So, in recent years, the market share of the cold fluid applied has increased, and that's why we're talking about it. And in reality, guys, this cold fluid applied wasn't even part of this program when they developed it. It's something that, you know, we just added in here because it was getting more and more prevalent. 5 years ago, I hardly used any liquid applied flashings on penetrations, and its whole job. I mean, it seems to be the way the market's almost going. What do you see on that, Glenn?
It's one of the fastest segments of growth in any of the markets, from SBS, APP, PVC, TPO, all the membranes that we're commonly used to seeing out there. This is definitely one of the fastest growing. I foresee, honestly, it kind of goes with the market trends as well. The economy goes kind of tanks a little bit. Everybody's looking how to stretch a dollar. You're going to see that it makes it every so often it becomes at the forefront of everybody's thought and how they go to market because of the price point that it presents. It's an economical solution a lot of times. But I can tell you that coming from the manufacturing side, it was something that they spent a lot of money on. I mean, a lot of money, and not just one man. Every manufacturer grasps it, and you're not going to see it go away. It's going to continue to grow. I believe as time goes on, you're going to see it. You know, back in the day, like Mike, you could probably chime in on this as well. But when I was coming up, it was all high, right? And then as technologies came and proved themselves to be longevity. To prove themselves to be worthy of putting into construction, if you will. More and more people jumped on the bandwagon, but I mean, there's a lot of money being put into research and development, because you don't want to just go sling something out there and go, oh boy, it was a mess. I mean, they put a lot of time and effort into it. And this is one segment of the market that there's a lot of R&D going on. I mean, to the tune of, I can't really divulge exact numbers because of contractual agreements, but I can tell you it's in the tens of millions of dollars, right, that manufacturers spend on this to get the best product, the most longevity. The problem comes in as you modify these products, and you're trying to produce a product that will encompass certain factors. And as you say, okay, well, this product, I'm gonna add it with this product and add it with that product. Well, you put them together and you find out that this one component doesn't behave very well with this other component. So that's where the chemistry comes in, and that's where the R&D to see not only is it going to mix well, but how's it going to perform over the long term. And so a lot of money, a lot of time and effort, a lot of professionals brought into this arena of the market to try to see how we can get into this market and jump into it wholeheartedly, as we've talked about before, as Europe has done. As I can tell you, Europe does a lot of this, and it's pretty much a staple for them. And in my perspective, coming from the manufacturing side and also on the contracting side, it's going to become more and more prevalent. So, you know, it'd be wise for the person who sees this technology to embrace it, understand the pitfalls of how and why it works and does not work, and what it takes to make a system effective. Once you understand those components, understanding the product becomes a little bit easier. So I could just tell you, it's not going away. It's going to become bigger and bigger. It's going to become more specialized, and it's here to stay for sure.
If I may.
I think I'm back.
You are.
Clay,
Am I back? Okay, good, because
that's why I stopped talking.
It dropped me. Okay, so thank you for keeping it
on. Glenn pointed out a couple of things that I thought I could speak on for just a few minutes. I'll keep it fairly short. About the popularity of systems, I think that what you find in general is that the popularity of any kind of recovering system now has gone up. The labor to remove roofs is not only expensive, it's hard to find. A lot of folks don't want to get dirty and remove these roofs. There's also, particularly in Florida, a lot of liability when you remove a roof system, particularly in the summertime. This last week's weather is a good example. So any system that you can control that removal process is looked at very favorably, both economically and from just getting the job done with the minimum amount of exposure. So I think that's driving a lot of the recovery in general. Thereby, it's even more imperative that we make sure that what we're recovering, how we're going about that, and what we're doing, and how if that system is going to hold up long term over the system we're installing. And always understanding that anytime you install a second roof system, there's a lot of things that are created by that. So you want to take advantage of that. Anything over 2 roofs, which a fluid applied roof system is a roof, you have to remove that roof system down to the deck. So anytime you put a second roof covering over an existing one, you have to realize you've changed things a bit. We'll probably get to that later. Thanks, Clay.
Yeah, but Mike, I hate to say it, but correct me if I'm wrong, because you and me talked about this, Glenn. This is a way that people get around that a little bit. To get around, they put down, they may not permit it, or they may not permit it as a roof system. They may permit it as a coating, but that's why what I learned about when I was putting this together is there's so much crossover and kind of gray area between the two sometimes. And I think especially maybe when you get away from South Florida and get away from the HVAC, there may be even more ability to...
Smoke and mirrors?
There's a lot of that takes place. A lot of it's like misnomers and misunderstandings, actually. The terminologies, as the technology becomes more prevalent, will become, like I said, more specialized. You know, we've had this conversation, Clay, and you and I have talked several different, well, many more than several different times about this, but the concept of understanding that when you're coating an existing system, it's a coating, it's an additive or an enhancement. That's one objective. Understanding the objective of the product or the system you're putting down is basically the key to understanding whether or not you're putting down a roof system. So if you're putting down a coating, like a surfacing, there's the gray area. But if you're putting down a waterproofing system that is supposed to be longevity, it's supposed to perform as a roof system, and it's the primary waterproofing barrier for the structure, that's where I believe that it becomes a little bit more black and white. But yeah, there is definitely crossovers. People selling coating systems, what I call, quote, coating systems as roof systems. They're selling them that way they're not showing up on permitting or that type thing, but they're actually being sold that way. And to me, that's a disservice to the customer. It's also damaging to the industry, in my opinion. But there is definitely a gray area, or still has not quite got unified. And I'm sure as time goes on, those things will get a little bit more clear. I know, like with guys like Mike and those guys that are working on the codes and whatnot, that they're the ones that are really hashing this out and making everything line up the way it's supposed to. So I'm sure as time goes on, it's going to get a little bit more crystal clear in that respect.
But just to be clear, what we're talking about here today are systems that can go down over secure rock by themselves. They can go down over plywood. Typically, you use a base sheet because you may want to get it off of there someday. That's why they're going to use a base sheet first.
Yeah.
Work over an existing roof, and I think Mike raised a real good point earlier in that if I put a roof over an existing roof, that new roof is only stuck down as good as the original roof that I'm putting it over. So if I put a roof, no matter how good that roof sticks to an existing roof, if the existing roof isn't stuck very well, the new roof isn't stuck very well. So a lot of times there's testing that needs to be done as far as uplift goes to make sure that you do comply with your new fluid applied system. Moving through it because I'd like to leave some time at the end for questions. Again, I want to go over the field conditions. That's why I asked Frank to join us today. That are what we see out there and the things that we're going to run into in the field. But we're going to talk primarily about, again, acrylics, polyurethanes, PMMA, which is polymethyl methacrylate, if you hear that, but it's PMMA, so we don't have to remember all those chemical terms, and PUMA. And the difference is, and if you looked at, I sent you some information from Tremco. Embedded in that was where they were doing elongation tests. And the elongation test showed you that the PUMA, the urethane-based product, stretched 400 to 500, maybe 500-600 times its original. But the PMMA maybe only 50%. So the PUMA better tensile strength. And so what I did was I tried to focus again on systems that could be permitted as a roof. So if you look at, and one of the shows, when you get an NOA, it has a category of roofing. Well, the subcategory is liquid applied roof systems. Products we looked at last week were also, their subcategory was adhesives and coatings. So a little bit different. They're going on, whereas what we're talking about today is a quote-unquote roof system. Those of you that work with C-Plast will recognize Parapro. Okay, Parapro is a product of C-Plast. You mix, that's one with the dry, right, Glenn? You mix it with the dry. So elastomeric. Anybody except the panelists for a Uber Eats gift card want to tell me what elastomeric means? So you may want to unmute yourselves.
The strength, the stretch strength, something to do with the stretching.
You're talking reinforcement?
No, how far it could stretch, like your flexibility.
Okay, the stretchability of it. Actually, Arstani, I'm gonna let you eat with that one. Okay. So elastomeric is a generic term for rubber-like roof coatings, anything that has the ability to return to its original shape after load is removed. Waterborne acrylic coatings are the most popular. There are many types of elastomeric roof coatings, and I learned that along the way. Elastomeric to me, I thought for some reason it was more of the rubber, but then I didn't realize that it was either, it could be acrylic, it could be silicone, it could be a polyurethane. All that has to do with the amount that it can stretch. And I think, if I'm not mistaken, the ASTM requirement is 100%. I saw that somewhere. I looked for it again. So basically, if something can stretch 100%, you could double its length, let go of it, it's going to return to its original shape. As you guys in my class, we talked about things like the elastic limit, and we looked at properties of materials. And you know, the elastic limit is that point to where you stretch it, you go to the original shape. You've done past the elastic limit. STADI. Okay, last week we talked about pigments, okay, and I just want to go real quick through these because, and again, coating, cold fluid applied roofing can be the same product using different methods. So we have acrylics, we have urethanes, they have the same basic properties and the same basic things, and the pigments are typically what provides color and UV resistance from the sun, okay? You have fillers in there that are just making up space a lot of times. You're probably spending too much for them. That's why they're just a filler. Modifiers are other materials added to assist things like wetting or promote adhesion. We talked about wetting. You guys that took the soldering class with me know wetting from when we soldered. We were wetting the material, and it was the flowability of it. To promote adhesion, change the viscosity. We talked about viscosity, and that's how something flows, whether or not it flows. Oil has viscosity. Some of you know that you work on cars, some of the oil flows good, some of it flows slow. So it depends on whether or not maybe I'm using my car in cold weather or hot weather. Reduce sag. Sag is when that coating might hang on the wall and then it drips within itself. Inhibit oxidation, weathering, and for a wide variety of additional purposes. Getting that coating there. It could be water, like acrylic coatings have a water-based carrier, okay? So it could be various spirits, mineral spirits, toluene, xylene, which those are solvent-based coatings because those are solvents. So if you look on the coating, and it's designed with special gloves. You don't want to use a glove that's leather or cotton when you're using a solvent because it's going to absorb the solvent. The solvent's going to then absorb into your skin. So again, always make sure you're reading your product data sheets, your SDS, know what you're working with, know the proper precautions, take the proper safety, because at the end of the day, that's your hand in the glove, okay? And again, the carrier is what evaporates and goes away. So you guys, especially from Jimmy's class, and we're on the call last week, if there's no type of coating product to know what its solids percentage. What is solids by volume or solid by weight. I go by volume because that tells me how much of that product is going to be left after it cures. It cures, all those carriers go away. That volatile stuff we talked about goes away, whether it be evaporation, whether it be a moisture cure, however that product cures, that part of the product goes away. What you're left with is all the solid stuff at the end of the day when it dries. When it cures. So you have solids by weight, solid by volume. So just as a little example, when you put down a product, and again, we did labs in my class, so we use mill gauges to measure a product's wet film thickness. It's a gauge you put down into the film. I don't know if anybody in Jimmy's classes had that yet, any of the modules that may use a mill gauge. But first off, it measures in mils. So what is the mil? I'll give a gift card. A mil is. How much of an inch? Do I have everybody muted?
Repeat the question. It's like you're cutting out a little bit.
You're Googling it. How much is a mil? 1 mil.
How much is a mil?
Equal to, not a millimeter. That's
the
a mil. M-I-L. So how much of an inch is 1 mil? I could have Googled it, and I'm 57 years old in that time.
You broke up a little bit when you said it, Clay. You might want to repeat that.
Anybody?
Thousand.
All right.
As far as what it is.
Yeah, you're kind of breaking up a little bit.
Yeah.
It's a
How much is the
thousandth
mil?
of an inch. 1/1000th of an inch.
A
So
millimeter.
when I say, no, not a millimeter. A millimeter is the metric system. A mil is the acre system. So 1/1000th of an inch, and inches are reuse. Okay, that's the imperial system. 1/1000th of an inch. So when I say gold metal, that's 40,000 of an inch. You guys know how much it is, probably about the thickness of a credit card. So what I want you to know, you guys put down, that's what you need to know. So not only do you need to know when you put it down, it's wet. So when it's wet, you put it down, it's the wet film thickness in mils. You're going to measure it. And then it dries and it cures, because we talked about dry last time, and we talked about dry being dry to the touch, dry to recoat, dry to walk on. We talked about there being a lot of different dries, but only one cured. It's either cured or it's not cured. It can be all different kind of dries. So when you have wet mills and you lay down some coating and you stick your gauge in there and you measure it, because it's gonna the last notch on that gauge that's got coating on it is gonna be the approximate thickness. When that coating dries, depending on the percent solids, like this picture shows, is what you're going to be left with. So if your coating's 50% solid by volume, if water is a carrier and
It should be 4. It should be 4.
is all the solids, the pigments, it's part of the product. When the volatile portion cures off, what you're left with is a dry film thickness. So if there's one thing you could walk away with, is being able to know what the dry film thickness is based on what you put down originally with the wet film and what your percent solids of the product is. So if I put down 20 is one of the test questions. If I put down 20 mils wet and my percent solids by volume, how many mils are in 5? So if you lay down 40 and it's 75% solid, you're going to be left with how many? 30, right? 75% of 40. Am I coming through clear, Glenn?
You're breaking up.
How bad?
Every other word, right now you're clear, but when you were doing the question, you were breaking up about every other word, sometimes 3 or 4 words.
I'm trying to sit different today. What if I talk slower?
What's that?
I can hear everybody else just fine. It's just you cutting in your words. So I couldn't really understand the way.
Clay, you're also, your video
Any
is
better
also,
now?
Clay, your video is also freezing up. So I think you've got a streaming issue. I just don't think you're getting enough streaming, because you're freezing up not only voice, but not only audio, but video too.
We're going to get through it.
Glenn, can you read them?
Yeah, I see it. Where he says coatings dry and cured. That's the slide that's up. The coating may be dry to the touch and yet not fully cured. Is that the slide? Curing mechanisms. Cold fluid products considered cured when it's achieved its ultimate performance characteristics. That means when it's cured, that product is final. It's at the state that it's desired or most desired to be at. Some coatings, they can take up to 30 days or longer to fully cure. There are 3 different mechanisms by which a typical roofing coating will cure. It's either evaporation, oxidation or reaction to moisture, if you will, or a 2-component chemical reaction. Recoat windows are critical, guys. When you're looking at a product data and you're looking to select a product to use, you definitely want to pay attention to your cure windows. If you're going into the rainy season and you're going to try to put down a coating, do you think you want something that's going to take 24 to 48 hours to cure, or do you want something that's going to cure quicker? I mean, those are the kind of things you need to pay attention to. And sometimes cure windows are the faster tend to be on the chemical reaction side versus evaporation. But along with that comes additional costs. So sometimes the cost of the project might warrant using a longer cure time product, if you will. But these are some of the mechanisms when we talk about how a product fires off or cures, if you will, then knowing how that process takes place is very key in how to select and use a specific product. Clay, are you back?
Glenn, I can.
Yeah, my connection is on.
I don't know if we've got Clay back. Kind of, sort of.
Kind of, sort of.
Yeah, guys, think about that, particularly when you're talking a water-based system. If you put down a water-based coating and you get a heavy rain afterwards, most of everything you've done is going to go down the drain, which of course is wasted money and can cause some issues, particularly out along the intercoastal, the beach areas like that. A lot of the surface water runs off, and even the surface water drainage systems run off into the bays and the Gulf, or over on the East Coast into the ocean. And if you haven't, just go to the roof and get a heavy enough rain, you'll have a great big white cloud coming out of where those drainage points are. And you'll end up getting visits from people you don't want to visit you. Because particularly with condos, there's somebody watching every move you make. And the minute something goes astray, they're going to be on the phone to somebody. And the next thing you know, somebody's showing up and telling you, oh, you've done some damage here. And then your boss is going to get unhappy. So make sure if you're going to put down a water-based coating, you've got enough time for it to cure. You back, Clay?
You hear me?
Yes, sir.
Kind of.
Okay, so we again, different curing mechanism. We talk about evaporation. Come on. About oxidation, reaction with more moisture. One of the main things we're going to talk about it, because we're talking about products that have A and B components to them. Still okay?
You're sort of, yeah.
My sound okay?
You're kind of breaking.
Not too good.
Go on, Glenn.
Even the slides are taking a long time, Clay. You've got a really bad, the output is pretty weak.
One of the key, he's got a slide up while he's working through that. He's got a slide up here. This is kind of near and dear to my heart. I know one of the last classes I taught with you guys there in Orlando, we were specifically talking about caulking and sealants, but it applies here as well, is adhesion. If a system, I don't care what the quality or characteristics of the system is, if it doesn't adhere, it's worthless. So adhesion is extremely important. It's one of the key and probably pillars of the system. It's the bonding, joining, or sticking of two materials together. That's what adhesion is. Whatever system you use should have a very tenacious adhesion to either a existing coating or whatever substrate or surface you're going over. So that leads me being a quality control guy, I tend to err on the side of testing things prior to just throwing them on there. So testing and making sure that you have good sound adhesion is always critical and key. And of course, that opens up Pandora's box of surface prep and those type things. But good adhesion, compatibility, knowing what the product is compatible with, just throwing it out there. Who thinks that a silicon's good to stick to a cured silicone? Has anybody ever tried that without any type of primers? And the new technologies I know are supposed to be good.
You can do that. Silicone stick to silicone.
The old silicone sticks to the new silicone?
Yes. Just gotta
silicone to acrylic.
No.
There you go. So knowing your compatibility, knowing what you're going over, and that the product that you're using will in fact work over that particular surface is key. And good adhesion. Compatibility is one of the key things. Surface contact area. Coating formulations are designed to wet and spread over a roof surface to maximize the substrate contact. What it means by maximizing a substrate contact, if you're flying along with an air sprayer and trying to apply a product with an air sprayer, you get, if you look at it under a microscope, if you look at it, the product hits, sometimes it actually will bounce. You'll get micro voids, if you will, under a system. Like it looks like Swiss cheese or craters on the moon. Having even and compressed adhesion, a uniform across the layer of product that you're putting down. That's the concept you want to always try to capture. When you're putting a product down, you're not painting, you're applying. And that's the mindset you have to have. But knowing surface textures, there's certain products that have to have a certain finish, a certain surface in order for them to perform the way that they're intended to perform. So knowing that factor, knowing the porosity, the coating viscosity, and application technique, they all have a potential to affect the contact surface interaction. So surface textures add grab, just throwing, say like a tilt panel wall, trying to apply a coating over a surface, kind of like a tilt panel, real smooth, real sheened surface versus putting it over a broom finished sidewalk, if you will. Which one do you think is going to grab more readily? Just throwing it out there. Would the smooth, shiny surface grab the product more readily, or would the broom rough finish concrete grab the product more readily?
The broom surface.
Absolutely. So understanding how that works, understanding the surface requirements. Roller application may reduce air pockets. Additionally, surface contaminants may negatively impact coating. So, when you're looking at a surface and you're not just talking about a confined area, but you're talking about a widespread roof surface, when you're cleaning an area, and Frank, you might be able to speak to this a little bit with the project that we've got out there that we were going to kind of use as an example in some conditions, is when you're cleaning a roof surface has been sitting there for a good while. So who knows what it's been exposed to in regards to service personnel changing out an AC unit to you name it. So if you go up in there and you just broom it off, sweep it off, and to the naked eye, it looks great, and you start coating, who knows what chemical contaminants you can run across. Or just simply the chemical interaction between a product with a surface, like EPDM versus using like a acrylic over an EPDM, knowing how the molecules or how those chemicals interact with one another. But knowing that and really paying attention to your product data is key when it comes to making that decision. We're not chemists, so we have to rely on the information we're given, right? So we have to go to that information readily. And understanding the concepts, understanding the vernacular, the terms, understanding that, it's daunting sometimes, but it all comes down to this. What are you going over? What type of surface does it require? How am I going to put it down? What's the best way to put it down as far as what tools am I going to use? What's going to give me my best adhesion? That's a key portion in how you're going to go about putting this product down. How am I going to put this product down? Clay, you back? Where's he gone?
He's muted right now, Clint.
He's cussing.
Yeah, he probably is.
Try me now. Can you hear me now?
Yes, sir. Sort of.
I'm trying. All right, thanks.
Deep
Give me
breath,
one
Clay.
second. There you go.
And
Can you hear me?
Yep.
yes,
I'm going to try to go my hotspot.
Okay.
I don't have good internet, obviously. Talk about cohesion.
We were talking about adhesion, so yeah, moving right into cohesion. Who knows the difference? Just throwing it out there. If somebody wants you got another card you can throw somebody? Play. What's the difference between adhesion versus cohesion? Anybody know? Just somebody chime in.
I think adhesion is how good it sticks, and cohesion is the force, like pulling it up, I guess.
Oh, not quite. Good try. Adhesion, as we said, was the ability of a product to stick to the surface, to a surface. Cohesion is the ability for it to stick to itself, and basically. So you got adhesion, applying to a surface, and cohesion, how it exists within itself, how it sticks to itself. Cohesion is also a performance criteria that's very important. So as we put these products down, a lot of times they're multi-phase. In other words, you have a base and a top, right? So if you put the product down and it sticks great to the surface, then you put the second layer down and now it doesn't want to stick to itself. Now we got an issue. So adhesion and cohesion, both sort of the same concept, but different. And when you're talking about modes of failure, if you look at a system and how it fails, you can have a product that bites real well to a substrate, but then for whatever reason, certain movement, or maybe it's moisture as your environmental conditions, as you're putting your second layer down, you come up against, just some bad weather, high humidity, low dew point, low temperature, whatever the case may be, and it can cause issues of the product actually adhering to itself. And then unlike PMMAs, after a product's been down for longer than 24 hours, there has to be a chemical reaction again. So you have to wipe it down with their solvent in order to activate it, so that the cross-link process by which it chemically bonds to itself has to be stimulated. You can't just paint over the top of it with apply over your existing with just the mixed product without having done that primer or that wipe down with the solvent, or you will get poor cohesion. So understanding that concept's key as well.
Testing 1, 2, 3.
You're good, man.
I'm on my hot now. I want to just say sorry, guys. Welcome to the new world. You got a roofer doing technology. I don't know what else to tell you. I'm doing the best I can under my circumstances.
Doing fine, buddy.
I got good backup. I'm good with my backup. That's my main thing. So what
Wasn't operator error, Clay. That was just bad hardware.
No, it's operator error. Look at.
I don't think
All right. So again, different types of coating. We're talking about acrylics. Acrylic binders dispersed in water and occasionally solvents, pigments, and proprietary additives. Again, they use a lot of acrylic coatings, but acrylic coatings are sensitive to ponding water. So you want to make sure that you have good drainage whenever you're using an acrylic product. Again, they're breathable, so they have a higher perm rating than your urethanes and your PMMAs. And when I talked about perm ratings last time, remember that moisture can pass through, vapors can pass through these coatings. That's what a perm rating is. So they're breathable. Acrylic binders may be formulated in trowel grade mastics also. So we use a lot of the trowel grade mastics, especially a lot of times with the acrylics on vertical surfaces. Polyurethanes, am I more consistent now with the speech?
Very much.
Good. Cured polyurethane. I wish I would have known sooner. They demonstrate good chemical and weather resistance. Their perm rating is down in the average of about 1. Solvent-based polyurethanes are not as sensitive to temperature as water-based coatings, but do require any of these products requires a clean, dry surface. Polyurethanes typically be applied to most roof surfaces, generally high in solids. And some of the polyurethanes that I'm looking at, and we're going to talk about today, 100% solids. That means if I put on 30 mils and it's 100% solids, when it dries and cures, I expect to have 30 mils of product. It's 100% solid. That same 30 mils, if I put on a 50% solid acrylic, I'd have half of that because it's 50% solids. So I'd only have 15 mils left over of coating when it cures. Acrylics tend to be low in solids. That's why when we put on acrylic products, we tend to have to put 2 coats on. You have to make 2 passes with an acrylic, because when they dry, you don't have enough mils to satisfy your warranty. Because as you know, just like with any of the products pretty much that go on our roofs, except for a couple of them, every year you lose a little bit of that surfacing on those products. They get a little bit thinner, just like TPO.
It froze again. You froze again. Are you there? Can you hear us?
Yeah.
I think one of the things too, until he comes back, one of the things that when we were talking about putting down multiple layers, when you have to go back and put a specific layer down and let it dry and then come back and put your other layer down, if you try to apply that product too thickly, that drying or curing or evaporation, then you're reduced to a certain solid mill thickness. That movement that takes place, if you apply it too thickly, you're gonna see it cause it to crack and alligator and flake. So that's one of the reasons that your QC guys, your manufacturer reps and that type thing are really, keying in on putting it down in a specific mill, so that you don't get that adverse effect from too much movement due to that evaporation process. You there, buddy? You back?
Doesn't look like it. Tough part is the slides aren't showing up either.
It's frozen on that one. There's his picture.
He's hearing us.
Okay.
I don't know if it's the weather. I don't know if it's the internet. All I can do is apologize.
What you can do is the best you can do. So
Keep going, man.
Let me get my screen back. I'm switched back to my house now, but it says my connection's unstable. Again, plural and so can you hear me, Sid? Can you hear me?
Yeah.
Take it away. Can you talk to it, Glenn?
I'm waiting.
Glenn, can you hear me?
Yeah, now, because I can see your slides too now. Everybody heard the terms, urethane, terms of note, aromatic. You got it.
Hey, can you hear me?
Yeah.
All right, terms to know for urethane, aromatic, aliphatic. Can you hear me? Hey. Glenn.
Yeah.
Mike, can you hear me?
Hey,
yeah,
Clay, you're
Clay,
breaking up.
Yeah, they're coming through. Hold on.
Can you hear me, Glenn?
Yeah, I can hear you. You're breaking up a little bit in and out, but you're keep going. I think you can keep going.
Right. Terms to know, aromatic, aliphatic. Aromatic's going down first. It's going to be waterproofing coat, down a 2-coat urethane. The aliphatic go down the second one. That's going to get you UV protection and hold the color. Again, aromatic and aliphatic. Aromatic used as a base coat, stable, pretty high solid content, tendency to turn yellow. That's why you put the aliphatic on top of it to hold the color, so it holds the color that you want. Low to moderate solids, UV stable. Uses a top coat. We talked about natural and bio-based products. What's happening is it's like ethanol and gasoline. A lot of products to have a LEED certification, incorporate, and actually a lot of oil and using waterproofing over time. This was actually nothing new, but it did fit the bill as environmentally conscious. And a lot of these products now, they want on a lot of buildings to use are environmentally conscious. We're going to talk about PMMA. It's a two-part methyl methacrylate, but it actually is an acrylic resin. You guys know what acrylic is. Very rapidly once you add the catalyst. So when we look at the data sheets, is these products have short pot lives. So you better be ready to use them once you mix them, because once you mix them, you may have 20 to 25 minutes to use them. Still okay, Glenn?
Yes, sir.
Okay. What happens is you may have 25 minutes to use it at 75 degrees. If it's 100 degrees or 105 degrees on the roof, that may be 10 to 15 minutes. So you got to be careful. And when you first mix these things, don't mix a lot of them, because you'll leave them, they're going to get hard in the bucket on you. PMMA fluid applied waterproofing, cold applied system typically consisting of primer coat, polyester fabric embedded between layers of PMMA resin. A lot of times, one of the key components of this, as Glenn mentioned, is quick cure time. So if I'm doing a parking garage and I have to stop traffic, I want to use one of these products so I can drive on it, again, within a few hours. The quick cure times. Another key component of these products is low cure. A lot of these products you can use at 0 degrees. They'll cure out at 0 degrees, albeit they're not going to cure as fast. Again, they go back to the 30s. They were initially very rigid, so they took some formulation to make them usable as a roof product. Again, they're good for penetrations. We use them a lot in liquid applied applications, those in the urethane. And where you need high abrasion resistance and resistance to things like vegetable oils and environmental contaminants. Puma, on the other hand, is a urethane-based, methyl methacrylate. So what you get with that is you get a lot better elongation and elasticity you do with systems. PMMA's molecular structure makes it suitable for fluid applied applications and construction. Again, a lot of times they use the technology between slabs and under traffic conditions. Won't get into too much to the chemistry. Over substrates, concrete, masonry, wood, gypsum board. Some of the PMMA Puma systems that you see out there, here's some of the manufacturers we see commonly in the marketplace. One of the things I noticed is when you're putting PMMA system, is this spiked roller. I had never seen it before. Glenn, have you seen them before?
Yeah, I have.
What that does is that will keep the bubbles and detrain, because you'll hear me say when I talk about mixing, don't lift the bit. You'll air and train the mixture. Mixture and air bubbles into the mixture when you do that. So what this is, untraining it or detraining it. My internet's still okay?
You're cutting in and out a little bit. You're okay though. We're hearing you.
So again, a big problem with these type of systems, making sure that you don't get pinholes in the system, and the pinholes are different things. Talk about reinforcements that we use in these cold fluid systems, primarily either polyester mat or fiberglass. 40 mil is a common thickness. Also, although I saw in your presentation, Glenn, that 50 and 70 mil are also sizes that are common in the marketplace.
Yeah, this particular technology it's very critical. Anytime you're using PMMA, anywhere you make an angle change where there's possibility of abstract movement, where you've got movement moving one way and then a penetration that transitions, right at that transition point is always going to be focused movement, if you will. And it's a common mode of failure on systems is that it has to be reinforced with fabric. It will only accommodate a small amount of movement without the reinforcement of that fabric. So the common thought was, and a lot of guys used to just, they would scrimp on how they dovetailed their wraps and that type thing. Anywhere there's a pinhole, anywhere there's no reinforcement in that liquid product, you're prone to having some type of fracture there. You got the slide up now, Clay.
So being trained in the system that you're putting down, very critical. I want to turn my computer off, but I risk losing everybody. You know that?
I would keep going. We'll supplement, man.
All right.
Yeah, the quality materials, you can have the highest quality material there is, but without practice, without training, without education, you're really no good. I mean, you're only as good as the guy putting it down, right? So, I mean, this is what this process is all about: being educated as how to use the product. Hands-on training is definitely the way to go because these are very I mean, you're going to see it, you're going to experience the tick, like he was talking, Clay was talking about the air bubbles in the mixture with PMMA. When you're putting down that product, you basically go back and start putting your top layer to get your 3-course in effect. As you're applying that, if you allow that roller to get dry, it starts plugging on the mat. It starts inducing air bubbles into the mix. And what happens is kind of like the old built-up systems. The guys used to holler at us when we were young guys. Don't step on my fly. Don't step on my fly. You get the placement of your liquid. It gives an avenue for water to work through the system and perk through the system. So, applying this product is very, very hands-on. You got to really watch how you're place the product on the deck and rock and roll. So quality materials, you definitely want to work with quality materials, but you want to have some experience with it. You want to get some hands-on. It's not I would just rush out there and go, hey, I saw a video, let me jump on it. Play with these things, practice with these things. 3 areas of concern that you really have to pay attention to. We've talked about surface prep.
Hey, Glenn. Hey, Clay. Can we get everybody who's not talking to mute their mics? We're getting a lot.
I'm trying to say. I was trying to do it from my end. I couldn't do it. Angel, can you mute your mic?
Yeah, I can do it now. Sorry for that.
Clay, what I would suggest is everybody who's not talking.
All right, thank you.
Because Glenn's even having a hard time getting through now. And it may be that there's too many microphones open. So if you're not talking, you want to mute yourself, everyone.
Okay, so yeah.
And Glenn, can you see if you can mute the group?
Yeah, I'll do it.
I can't. Can you hear me?
Yeah.
Okay, let me go back then. Again, so one of the main things to do is evaluate your substrate and your surface. Not all roofs are candidates for liquid applied systems. They're not all candidates for coating. So surface prep is key. You want to clean the roof. A lot of times, simple green is the common one with a little bit of agitation, although you want to make sure and check with the manufacturer of a proprietary system, correct, Glenn, that they bring out, or did they use that, Frank, at the courthouse? Glenn, can you hear me?
Yeah.
Did they use the proprietary cleaning system at the courthouse?
Yes. Frank, can you
Yeah, hey Glenn. No,
Am
what
I
we
fading
do,
in and out?
yeah, hey Clay, out there at GSA Courthouse, we didn't use their system. We were just required just to pressure wash the mod bit roof, and then we scarified the concrete deck that we coated.
And you know, one of the things I want to do is get to the concrete prep. I know we're having a little technical difficulty, so there's a couple things I want to hit on. Again, you're doing a metal roof. Mike, you can hear me? Mike? Okay. You want to make sure that if you got a metal roof, you're going to need a primer. Wherever you've got oxidation, there's no doubt. So if you got metal that's rusted, you need a primer. A lot of these systems go over built up and modified bitumen roofs. So we use them as in a recover situation. But again, not all roofs are good candidates for coating systems. Existing.
Throw something in real quick.
Yes, sir.
Guys, there was a picture a couple slides back of a skylight that matches the corrugations of a metal panel. You really ought to be very cautious about coating over a skylight with the same color coating that you're using over the metal. It creates a very dangerous situation. People can't see that it's going to break through. They step on it. And if you do decide to coat it with the same color, you should clearly delineate the perimeter of it and put some kind of a no step signal on it. Preferably, if you're going to coat the entire roof, pull those skylights out and replace them with metal and eliminate that fall through, because there have been some very serious accidents where people unknowingly stepped on those skylights and went right through. So keep that in mind. And even if your boss is asking you to do it, you might want to bring it up and say, hey, is you sure this is a good idea, before you actually do so.
And good point, Mike. One of the things I do is I always go inside, because a lot of times you will be able to see them from the inside. The rest of the structure will tend to have an insulation mat applied to the underside, mat insulation. But if you will tend to be able to see them if they've done that, and I call them filmmakers.
Yeah, and Clay, you're still breaking up some, but guys, if you get up on one of these type roofs that usually have some skylights in them and you don't see them, be very cautious. Start looking for them, because what you may find is they're there and they're hiding from you and waiting for you to step on one of them. If you look close, you can usually tell the difference, but you've really got to look very close. So if you get on a pre-engineered metal building and you don't see skylights and it's got any age to it at all, take a real close look and see if you can't figure out if they are there, and then if they are, how often and how they're spaced.
Mike, I'm trying to change locations again to see if I improve my reception. Please.
As the next slide, we're talking about different methods of application. You've got an airless, which you saw some pictures earlier, but I think of an airless being used where it is pumped hydraulically through the system and comes out as a spray. It can be, a real quick way to apply things. You've got to be careful about the millage, because you can change the color a lot quicker than you can get the proper amount of millage down with an airless. You've got to make sure that you're getting enough coverage Rollers, brushes, and squeegees, they tend to all, as you use them, if you're getting a good covering, chances are you're probably getting close to the millage you need. You obviously need to check. And a lot of that will depend on what type of product you're using, whether you're going to use one of these three systems. Most of them will work with any of the three, but particularly when you get to some of the real thick products, or if you're mixing a two-component system, you obviously have to have an airless that's capable of mixing those two components. So that's normally how they will go down. I noticed in a lot of the video that we were sent to watch that a lot of this is poured right out of the bucket, and then you go to work with it. And those higher viscosity or thicker products, that's usually the best way to go about it. Looks like you might be back, Clay.
Yeah, how's my reception before I try to move outside? Better?
Much better.
Much better, Clay.
Thank you. I relocated again. I apologize. And I'm going to have to go get my battery charger now. One of the things I did want to bring up as far as application goes, Mike, is if you're using a solvent-based product, to make sure that you have a solvent-based roller also. There's different rollers that are better for water-based product, and then there's rollers that are made for solvent-based product that'll last a lot longer.
As you these different products and the chemical names and all the different types of products, nobody expects you to come out of this class and remember all that. I don't think there's anybody here today that understands all of the chemistry involved with these products, and for that point, even the application methods vary an awful lot. And the roofing industry and the products we're using are getting more complex every day. And I mean, every single day, there's something that's been added. We really have to rely on the independent technical reps that the manufacturers have out there. You can't know everything about every system, no matter how much you try. So you need to lean on an expert that spends most of his time installing a particular system. And they're an integral part of our industry anymore. And if you've got a manufacturer that doesn't have a good technical rep available to you, and in many cases a good field rep, you may want to be looking for a different manufacturer. It's an awful important part of what we do now.
Learn that the hard way sometime. How about you, Lonnie? You still out? Lonnie and I were talking about a little story about a field rep this morning. Am I okay now?
Yeah, you sound
Or am I
better.
still breaking up? Okay. Again, application, brush or squeegee. We talked about the notch squeegee last time. You can get notches on your squeegee that will deliver you a specific mill rating. So you can order your squeegees as such. Lonnie don't like squeegees. Application of multiple layers. One of the things I see in the field a lot of times is people put on the second coat the same direction as the first coat. You always want to make sure you go 90 degrees to your first coat. So if you go north-south on your base, you want to put your top coat east-west. Reinforcements may be required based on the deck type or to meet the specific warranty requirements of the proposed system. And again, we talked about reinforcements of fiberglass or polyester mat. Also, with multiple coats, one of the things you got to be concerned with is recoat windows. Frank, you want to talk to recoat windows a little bit? You're dealing with that at the courthouse.
Yes, well, we had, what we were applying was the TerraPro 123 system. Well, I'm sorry, I got the wrong job in my head. We were doing the Tremco BioGuard, and when we had the primer was installed on this concrete deck, it was scarified to a 4 to a 6, and we went ahead with the primer. We had a full-time Tremco rep on site for us, and he was kind of giving us the blessings of the install process. So we were doing the primer. The primer had a 3 to 4 hour window, to cure before we went with the first base coat. And so everything was just staged. Basically, after we did the primer, we waited 3 to 4 hours. Then we went ahead with the first base coat and installed the fleece. And then we went ahead with the second layer of base coat. And what we had a problem out there was within 6 hours after the second layer of base coat, we started noticing we were getting a lot of bubbles in the system. So we went ahead and stopped at that point there. And we were, right now we're waiting for Trumco to come out to figure out what the issue was. So prior to that, I went back into some moisture testing on the concrete, drilled some holes down to 1 inch. And I found that there was moisture in the concrete. It ranged from 16% to 26% in other areas. So we're waiting now for Trumco to come back out, and they have a solution, but they're not really saying what it is yet. Once they come out, they're going to do their solution in a 10 by 10 foot area, wait for a couple days, and then to see if that's going to cure the problem. If it does, then we can move forward and remove the roof system that we installed and install new material.
And Glenn, and some of what I've read and what I've learned recently in doing this, one of the things that's existing construction that has such a high concrete moisture content, which is kind of look crazy, Frank, because, you know, a lot of times we deal with this in new construction where as the concrete reaches its 28-day strength, the moisture content reduces. And Glenn, correct me if I'm wrong, the moisture content allowable to coat, I believe, is 5%.
Yeah, that's Mike might be better at versing this as far as the code goes, but the way it reads, you have a surface substance, and it tells you the tolerable amount, but then you find there is gray areas as far as depending on what that surface is being used for.
If I can, Glenn mentioned that when concrete cures, it's a chemical reaction, and the only time, particularly in Florida, the time you'll get typically your best cure in the summertime is right after that chemical process has stopped, because it's so high in the air here that once that stops, it more often than not, it starts absorbing some moisture, not losing moisture. As you know, take a day like today, obviously, if this gets to that concrete, it has a day and it gets wet all day long, you've lost that ability to get that chemical cure. And so it will take a long time in Florida for that roof to dry out. We did a lot of asphalt over concrete, and Glenn will know this. We had a real easy way to check and see if concrete was too wet or not. You took a little hot asphalt and you poured it on the concrete deck. And you let it set up, and as soon as it got hard, if you could peel it off the concrete easily or at all, it was too wet. If it stuck and you had to scrape it off with a scraper and it was still stuck to the concrete, some of it was ready to go. It's a lot harder to do that with these chemicals, and I've actually heard of some guys that still will carry around a little thing that they can heat up with asphalt to put concrete to test it, because it is a real good field test of whether the concrete is dry enough or not.
And we used a mill gauge. One of the things, a lot of times people think more is better, but you need to make sure that you're putting your applications of these products on at the correct mills, okay? You want to make sure you got the correct millage when you put it on so that it cures within the required time frame. Again, you want to be on a multi-employer job site. You want to make sure that your product doesn't get damaged by construction traffic. Single component modified urethanes are more susceptible to water absorption than multi-component materials.
Hey, Clay, if I may also include when you're doing a multi-layer system that you're going to want to do mill checks quite often, but you're going to want to do it on each layer. Don't wait till the end to do your final mill, because you want to make sure that you're putting all your layers down an acceptable rate. If it calls for 32 mills, then you have to have 32 mills. So
Frank, on the job you're doing, do you have a different millage for the top and for base versus top coat?
well, basically it's going to be all 32 mils. So the final coat or the final thickness should be up to a 96 mil.
You will see some systems that will vary though. You'll see some that the base goes down at 1 mil and then the top layer or the intermediate layer, depending on the system you're putting down, goes at a different mil. So to speak to what you're saying, Clay, you definitely want to pay attention to that millage. So you want to be putting it down at that, not that you're going to be exact, but you want to be monitoring that you're trying to achieve that specific millage, as that millage gives it the optimum cure time or cure window, if you will. It also prevents it from, some type of detrimental movement because of the cure. And it also is going to be a lot more price conducive at the end of the job when you're not ordering another pallet of goods because you said more's better.
And again, that's one of the things about these systems, Glenn, that is key, is that you really need to pay attention to what you're doing, what the specification is, what your ambient conditions are for application to get it right, to be successful. So some of these things that I put here are, you want to know the required thickness, just like we said of each application. Want to know the system coverage requirements based on the substrate. Review any of the system modifications required for warranty. Sometimes if your client wants a 20-year warranty and you got to provide a 20-year warranty, you may have to add that reinforcement mat. You may have to put product on at a different millage. Maybe you have to add an additional coat. You want to know what the percent solids is. That's on the manufacturer data sheet. How much material is actually in the bucket. We talked about that, and the Tremco Alpha Guard specifically, when I was looking at the two data sheets, and Lonnie, if you were having trouble speaking, you were texting me a minute ago. I know you can talk to this because you mentioned it last week. The base coat has 4 gallons in the bucket. I think the top coat has 3 and change, right, Frank?
Yes, sir. That's it.
So if you think you're using a 5-gallon bucket, it is not 5 gallons of material in the bucket. So if you're doing your grids and you're trying to put down X gallons per 100 square feet, know that your bucket is not a 5-gallon bucket, or you are going to be short. And
Like the bags of potato chips these days.
Oh yeah, it's all air. You're buying air. So gridding the roof, make sure somebody's got that does good math that's doing that, because that's a math calculation. But once you know all your parameters, what you need and what you got, all it is math. So you want to monitor your wet film thickness, WFT, with the mill gauge, and always consult the system manufacturer. Get them involved from the start. You don't want to have a problem in the field and find that out halfway through the project and then start your conversation with the manufacturer. Probably not going to go well. Here's the job in Fort Myers where we're mixing on the left, where you notice we're adding 1 gallon. We're adding the A and the B to mixing together. We've already pre-mixed the A. So the A component, you want to mix it by itself and then add it in. Now with this, you have to watch your mixing time. So there's specific mix times. So again, you'll notice compared to last week, these products are much more critical as far as installation guidelines. Still coming through okay?
Very good.
Okay, good. Thank you. Closing strong. And again, that bucket in the middle, only 4 gallons in it. Notice it because it's not a true 5 gallons. And then there's actually Frank in the picture doing the timing of the mix. And also you want to make sure you have an electric drill, and a hefty electric drill, because of the viscosity of the material. Okay, so it's not lined paint, it's thicker. So you're going to burn your drill up if you don't use a good quality drill. If you use an electric drill, a battery, you don't want to use battery operated equipment, because you don't want to be halfway through the mix and have your battery conk out, because it is very specific as to the timing. So I'm not going to go through the grid calculation again. We did that good last time, but gallons per square, you need to know. Lonnie hit it on the head. last time. He won the gift certificate. But again, we're talking about urethane. So material often 100% solid. And I'm using a 2-part, and I need 32 dry mils. Well, here's a trick question, or it makes you really remember. So how many gallons per square do I need? Well, if you remember from last week, I said any product poured out on a roof over 100 square feet, a gallon of that product is going to give you about 16 mils wet. 100% solid means that if you have 16 mils wet, when it dries, you're going to have 16 mils. The same. It's 100% material. So if I need 32, I need 2 gallons per square to get to that. So how many buckets per square? Anybody want to chime in and answer this question for a gift certificate? Anybody still on the call? Frank, am I talking to you and Mike and Glenn?
I hear you.
Arstati, how many buckets do I need per square? I just gave the answer. Last slide.
I think it's 1.5 square for 1 bucket.
Dude.
No, you forgot to ask in the bucket. Because I just told you the bucket's not a true 5 gallons. And I the question, so I ask you, how many buckets? But you don't know how much is in the bucket. You can't tell me unless you know how much material is in the bucket. So again, if there's anything I want you to walk away with from this conversation today, we did dry film last time, we did wet film, and we talked about wet film thickness, is to know that a lot of these products, especially the 2-part products that you get, are not true 5 gallons when you mix them. So if you think you're using 5 gallons, you're not. So whether you're ordering, whether you're loading the roof, you bring a crane out, you load the roof, you think they're all 5-gallon buckets, you've got 20 buckets, you got 100 gallons? No. You might, if you've got top coat, you might have 20, 30% less than that. So you have to call the crane out and load the roof again. So you want to make sure you always know how much product's in that bucket. Grid in the roof, I didn't pull this example up last time because it came from Tropical and we had GAF, so I didn't want to hurt his feelings. So when you're considering liquid applied, compatibility we talked about, suitability for the purpose, the coverage rate, what's the cost, okay? But there's 1 or 2 more things I want to get to before we get done today. And one of them is QC, since I got QC on the line, because moisture in these systems is a huge problem. So not only do you have a temperature range for application, and it says it right on the spec, only apply this material between this range of temperatures. You need to know what the humidity is, because your humidity over a certain percent, you can have 100% humidity. That is rain, but it may not be raining. So you have to be sensitive to what your humidity is, and they make ways to measure that. Dew point, because the dew point is where the moisture is in the air. You could get condensation because of the dew point. So you need to know where the dew point is, because you don't want to apply it when you have condensation. You may not have rain, but you may have condensation. Surface temperature is huge in what we do. So you got to be very careful with the surface temperature, and even bigger than it is moisture content in the substrate. Frank spoke to it earlier about being cautious as to moisture content. And as a contractor, we're all contractors out there, you want to make sure on your end you're doing your due diligence. So just because you have a representative from the manufacturer out there, don't let that be a reason for you not to do your own moisture test, not to do your own adhesion test. You want to do your own due diligence to make sure you have a successful installation. Again, different substrates. He's going over concrete, insulation, base, sheet. We're in existing roofing. When I look at some of these systems over concrete, these Puma systems, which is actually Volcom, I learned too as far as Tremco. The Tremco's Puma is their Volcom. You had uplift pressures in the range of unbelievably tenacious adhesion to concrete with these systems. That's why they're parking garages. That's why you can drive on them, because they're hard too. So there's a lot of ways to prep this concrete. And one of the things I wanted to touch on today before we go is this concrete prep, and we'll finish with concrete prep because we're running out of time. And I told you all we get off here early today. Frank, you used a scarifier at the courthouse job to get a of concrete surface preparation. And you want to talk to that? And I thought this was a great slide as far as different type of coatings and toppings and how you want to prepare the concrete, because depending on the coating you have, you prepare the surface of the concrete differently to accept it. So Frank, if you would.
Yeah, we did. We had to get a CSP, a concrete profile between between a 4 and a 7. What that slide showed was a CSP 6. That was surprising because I thought it would be a little bit higher, but Tremco was there. They came out with their templates and they gave it a CSP 6 on that one. But we're also doing another job in Sarasota. It's a C-Plus Parapro system, and that system needed between a 2 and a 4. So obviously we just had to use grinders on these little parapet walls. But the scarifier gave it to our CSP 6 at the GSA courthouse. But also with that said, by doing the scarifying that we did, it caused divots, and the divots were in question about, is that why we're getting the bubbling? So once again, we're waiting for Tremco to come back with a alternative fix for this problem. But,
and I would think, Frank, just thinking about it a little bit, like a divot is going to be deeper material, so it's going to be thicker there. So you may have a different cure time within the divot than you do on the top of the high point, so to speak. I hope everybody had time to take a look at the videos that I sent. Pretty good, I thought, as far as preparation. This is one of the first questions you ask if you're going over concrete and you're removing an existing film. What type of surface do you need? Because if you use the wrong machine to take the material off, you're going to have to use the right machine over bare concrete just to prepare the concrete. So you're going to have to redo it all again to make sure, because different materials take a different porosity and roughness of the concrete to perform well. And the CSP is basically the height between the high point and the low point of that concrete. And one of the things, and we talk about this, we'll write out of the spec for, for some of the products that they use. I wanted to point this out. It says it right here. You're looking for a CSP on this product of 2 to 4. You need to use a moisture meter to test the concrete to make sure that it's lower than 4.5%. So this is right in the manufacturer data. So if these are things you're not doing, guess whose problem that becomes? It becomes your problem, because they've already told you about it. Like I say, be cautious of the small print. Again, mixing, you don't want to get air in your mix. And again, another thing with these products, very specific as to manufacture date and shelf life. You want to be cautious that you're not using products that are out of date. In fact, some of these products, when they get old and they sit on the shelf too long, they become volatile, which means they can, I've seen the lids fly off the cans all by themselves sitting on the shelf. When they get hot, you store them too close to the ceiling in the warehouse. So you need to make sure that any of these products you're using are not expired. We talked about just different, we'll go through this in the lab. This is just basically the tools you'll need, some of the installation considerations that you have. And where we see these products a lot are planters. So if you haven't in your career yet come across the opportunity to do a planter, you very may will over time. And again, not easy detailing. You look at the one in the middle, you can barely stand in there, and you have to work in there, and you have to apply fabric in there. You have to detail that pipe where it comes up. You have root guards that are in there. You have drainage mats and protection layers. So being good at a planter is almost an art amongst itself. And again, we talked about the importance of weather and weather considerations. And when you have coatings, a lot of times you have VOCs. And we talked about VOCs, which are volatile organic compounds. A lot of time VOCs are not the healthiest thing to be breathing in on a daily basis. So one of the things you want to be concerned with is something that is a PL. What is my PEL limit? What's my personal exposure limit? You'll find this all out throughout OSHA. You always want to know it. It's going to affect how long you can listen to loud sounds. There's a PEL limit for loud equipment where you don't need to have ear protection. There's PL limit for different chemicals where you need a respirator. So I wanted to familiarize you with the PEL limit and what it means today, because again, starting and ending on safety. A lot of times what we do, these coatings can be real slick, especially where you've had ponding water when they get wet. So we broadcast aggregate in there and then put another thin layer of coating. We kind of create a walk pad. We may do it with a different color. And Glenn, correct me if I'm wrong, I saw something along the way, and Mike, you'll know about this too, walnut shells.
Yeah.
Heard of that?
Yeah, you typically see that with your bio products. That's just one part of the stick. I don't know what the performance advantage is in regards to, is more longevity, or I just know it's a big thing as far as bio products. It goes further in regards to lead, that type thing.
Is that, but that's right, walnut shells though, right? Have you heard it for the non-stick? Yeah.
Yeah.
That's news to me. I know I was talking about whether you wanted to lick a root last week or not, but I didn't get walnut shells. Wasn't part of that deal.
Hey, I want to get in on that gig.
So again, main thing I want you to walk away with is the different types of coatings we talked about, liquid applied systems.